Welcome back. In this video I'll be solving Leetcode problem 889, so the last combination, constructing binary tree from preorder and postorder. We all know what's about. I can see high acceptance rate, so maybe it will be easy, but yeah, it starts. So first, for sure, if there is no preorder or not postorder, then I return none. And for sure we can build root from preorder, let's say. So tree node preorder of 0. And now we have to see how do we build root.left and root.right. So let me first write root.left is equal, so construct from pre-post preorder post order. Now let's see how are we going to build this. So left side, I can see from example here. So the next one is left node, and I can see here next one is right node. And since I know that the left subtree will be first done, so either, okay, I think I got it. So I think I kind of got it. So preorder 1, 2, 4, 5. So on preorder we know that this node, next node to the right, is either left, so left subtree if exists, and a root of a left subtree, and node over here, and in post order we know the next one from here is the root of the right subtree if exists. And if it doesn't exist, then it's the last node in the left subtree. And if this does not exist, then 2, 4, 5, the next one is Okay, so I need to check but am I sure about this one? Because if I don't know, yeah, so the next one to the left is either root of the right subtree doesn't look so easy to me. So for sure what I know that it has to be from 1 up until something, and post order is from something up until -1. But if there is a right subtree, I think I need to check if call it air sub is equal to preorder of -2 preorder of -2 I think I need to check also, so if post order -1 is not equal preorder 0. So if this is true, there is either left or right subtree or both. So left or right or both. Okay, and now I need to think of how do I know if it's left or if it's right. My currently problem is that if there was no 2, 4, 5, next would be 3, 6, 7, and here I would have 1, 3. Something is reversed. So if 2, 4, 5 did not exist in preorder traversal, I would first go to root, then I would have left child non-exist, so I would have them 3, then I would have 6, and I would have 7, and in post order I would have 1. I would have so 3 nothing, then left, so nothing. I would have 6, 7, 3, 1. Imagine that situation. So I have 6, 7, 3, 1, and I have 1, 3, 6, 7. Well, if they are not the same, there is something in between. If they are not the same, there is something in between. I need to find ID of something in between. So preorder of something in between. So of 1. Order index of preorder of 1. So the next one. So I need to find what's the index of 2. And that is the new. So post order goes to ID x plus 1. And preorder goes to 1, 2, 4, 5, ID x plus 1. So 2 is here. 4, 5, 2. And I need from 2 up until what? Well, the last one, I would say. So in Postorder I had 4, 5, 2. Something like this, I think. So preorder index postorder -2. So from 1 up until idx2, and root dot right is equal to self dot construct from pre-post. I would say preorder from idx2 idx2 up until end, and postorder idx of 2, that's here, it's 1 up until -1. So something like this. Not sure about it, but let's try it out. And so what? I'll just add 1. Well, this is true all the time, actually. So this was a bit of stupid idea. So I need Postorder is greater than 1. This is something I need. Okay. Hmm. 1, 2. Well, I know it's 2. How do I know it's left and it's not right? That's what's bugging me. So in preorder, I would go root, left, right. Root, left, right. And here I would go left, right, root. So I think there is 2 solutions actually, and I didn't treat it correctly. Come on. Okay, I think I got it. I think I got it, yeah. There's always 2 solutions, so yeah, stupid of me. You don't need to think that much crazy, so let's think again. So root, let's delete these, let's delete these, 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 and these, and these, and we'll see now. Yeah, there is always multiple possibilities, so yeah. So this part is correct for sure. I build with preorder and I know that next one is either left or right. How do I know it's left? Well, I know it's left because I know that this one is left if this one imagine if only this subtree exists. So it would be 1, 2, 4, 5. 1, 2, 4, 5, and post order would be 4, 5, 2, 1. Okay, so if length of preorder, they all need to have the same number of nodes, is greater than 1, so I have at least one more node, then I have to check if there is only one subtree, it will be left. So if preorder of 1 is equal to preorder of post order minus 2, post order minus 2, then I have only left one. If there are both of them, then I need to figure it out. So if there is more of them and they are the same, then the left subtree only exists, and I go from 1. Imagine there is no, so 3, 6, 7. I would go from 1 till the end, and in post order I would go from the beginning till the last one. 4, 5, 2. 4, 5, 2 and 2, 5, 4. 2, 4, 5. Okay. And now I have situation where both of them exists. Then I have to play with indices, and they are not the same. And since this is not the same, so here is else. I stopped the order a bit, so copy this. So now let's see. So I know that I need, this is what I need. I need ID of in preorder index of post order of -2. So I need index of this one. And then I know from that index on, that's the right side. So IDX on, it's right side. And for post order, I'll need to do it some other way. Oh. IDX1 will be post order index of preorder of 2. So for the right, I take preorder from this one on, and post order I take from this one on, but without that one. So from IDX1 + 1 till -1. So I don't take the last one. And here then, from IDX, here I have to go from 1 up until IDX, and here I have to go from actually beginning up until IDX plus. So post order index of preorder of 2, and to include I have to take it like here. Okay, this seems it to me. Let's see. Let's see what's the issue. So pre-order is this, post order is this. 2, 4, 5. IDX1 plus. Okay, again, so 2, 4, 5. Here we got only 4. Post order. But this should have been, so I had IDX of not two, but one. A lot of mistakes. Maybe this will work. And yeah. Whew, so it wasn't easy, but I got it working. Is there a better solution? Well, yeah, this is more like it. So yeah, kind of straightforward, but there is this case where we need to choose which subtree exists. Let's see, time complexity, space complexity, but essentially it's the same thing. So of n squared, and again of n squared. So we have to we have n calls, and in each call we have to do this string slicing. So n squared worst case, and for space we also have recursive stack and this string slicing. So yeah, is it correct? Can't see it. Shame. Yeah. Well, this was a bit longer one, but this was the first time I was solving this, so yeah, it takes some time to figure it out. But yeah, if you have any questions, you know what to do with them. I appreciate you for following this one, and I hope I see you in the next one.